today's lesson we're going to look at how we find the equation of a straight line when we are given the straight line itself. It's therefore important that you've watched all the videos on linear graphs to date. Now, in keeping that in mind, we're going to do a quick recap on what the gradient of a straight line as well as what the y-intercept, because these are key to what is within the equation of a straight line. We also know from previous lessons that if we are given the equation of a straight line such as this, y equals 4x minus 1, how we are able to draw that straight line when given an xy table and an xy axis. Alright, so this is the general equation, a formula of a straight line. Okay, it takes the form y equals mx plus c. Y and x are the y and x values for specific coordinates along that line, and m is the coefficient of x, which is the gradient of the line. So we know gradient from previous lessons is the steepness of the line. A line going up the way like that is positive and down the way like that is negative, and c is the value for the y-intercept. So basically we can simply find the equation of a straight line if we know both the line's gradient and its y-intercept. And in today's lesson we are going to actually have the graphs in front of us, so it should make it that wee bit easier for us. And again, to look specifically at the equations of a straight line from previous lessons, we know how in the last lesson to plot these lines if we were given their equations using an xy table, substituting the values of x along the x-axis into this. Okay, I can tell by looking at this particular equation, if I was given this equation of a straight line and asked, okay, without drawing or plotting it, what is the gradient, so the steepness of this line? Well, the gradient would be 4, because 4 is the number that is the coefficient of x when y is the subject. So basically what you're doing is to find the gradient, you're looking at the number that is beside x. And the y-intercept is this value on its own. So the y-intercept being a coordinate where the line cuts the y-axis, this will cut the y-axis at the coordinate 0, minus 1. So even if I was just to give you an idea, draw a rough sketch, the y-intercept, let's say that was 0, minus 1 there. This obviously isn't drawn on the scale. This line would have a positive gradient of 4 going up something like that, probably much steeper in reality, and cutting at this point 0, minus 1. Okay, if I was to look at this equation and I was asked what is the gradient and what is the y-intercept, well, the gradient is quite simply minus 2. So this would be a line that goes down the way. I'll draw a rough sketch of it in a wee second, and its y-intercept would be 0, 1, because that is a positive 1. So the y-intercept coordinate is 0, 1. So again, if I imagine just a rough sketch, that being 0, 1 as the y-intercept, this would be a line that goes down something like this. And again, I could plot that given the equation. Okay? So we're kind of working in reverse from that. We're looking at how we find the equation of a straight line when we are given the line on an xy axis. So basically what we have to do is, using this line, we have to find both the gradient and the y-intercept. Well, the gradient we know from previous lessons is vertical over horizontal. What I mean by vertical over horizontal is I pick any 2 points on the line, pick exact coordinates, and I make a right angled triangle going down and across. I mean, I could pick here and here. I'll pick the 2 points that are further apart, just for example. So vertical 1, 2, 3, 4 is 4 squares. The horizontal is 1, 2, 2 squares. Vertical over horizontal, 4 over 2, 4 divided by 2, which is just 2. All right. The y-intercept, well, we just read where the line cuts the y-axis. It cuts the y-axis at 1, so the y-axis or the y-intercept is just positive 1. All right. So using the gradient and the y-intercept, bearing in mind we understand the equation of a straight line is y equals mx plus c. M is the gradient, which we've worked out, so y equals 2x, and my y-intercept is plus 1. So this line would have the equation y equals 2x plus 1. So again, if we are given the straight line and an xy axis drawn accurately like this, we can work out the equation of the straight line just by looking at it and doing very simply vertical over horizontal for the gradient and just reading off the y-axis for the y-intercept. All right, we'll look at a second example. Okay, so just keeping in mind this is going down, so for again we're going to find the gradient and the y-intercept. This, of course, we know the line goes down the way. Again, from previous lessons, a line going down the way is a negative gradient. Pick 2 points in the line. Well, I'm going to pick here, and I'm going to pick here. Here are 2 exact points. So vertical over horizontal, down and across. So this has a vertical distance of 1. Here has a vertical distance of 2. So the gradient is vertical over horizontal. So it's minus 1 over 2, which we can just leave as minus a half, or again, doesn't matter if you were to say it as minus, we know a half is 0.5, so minus a half is minus 0.5. You could do that as well. Now we just need to find the y-intercept, and we just read that value off the y-axis. Okay, so the y-intercept is 0 minus 2, so it's just minus 2. It's just whatever value is on the y-axis. So the equation of this line, bearing in mind y equals mx plus c, just substitute these values in it, we know. So y equals m, which is the gradient, is minus 0.5, or you could write a half x, that's fine too, plus c, so that would be plus minus 2. Well, you could write plus minus 2, but plus minus is the same as minus, so minus 2. Okay, I'll put some examples of this type of question up, and anything you're unsure about, just ask. In later lessons, we will also look at how we find the equation of a straight line when we don't have a graph to look at and we're maybe given 2 coordinates instead.